So I guess one of the things that I think I take away from both the gasoline example, the kind of short run, long run, as well as our discussion of productivity growth, is that capital and the adjustment of capital is a very important part of many problems. It explains the sort of response pattern we saw to gasoline prices. The response to capital also explains a lot about why productivity growth disproportionately goes to labor. It explains lots of patterns. Somebody asked earlier, and I don't want to skip questions that people ask. You asked about permanent technological change. And the way to think about it is, when will we get all the way back to here is basically when if you think about a world, like think about cars and think about the time it takes to get to here. What determines how long it takes to get to here? We just had a discussion with some people about that. Basically the life of cars. How durable are cars? If cars last 2 years, then we're going to replace most of those cars over a relatively short period of time, and we'll make our way back over to here. If cars last 100 years, it's going to take us a long time to get over there because we're going to have big cars for a long time. And so the rate of convergence to what would have been the steady state depends upon the depreciation rate of the assets that are causing the slow adjustment. So in the case of automobiles, there are really two types of assets that were important. One of which is the cars themselves. The cars themselves depreciate, how long do cars last? 7 years, 10 years, that kind of order of magnitude. So we're going to have kind of a roughly, 3 or 4 or 5 year half-life here in terms of converging to that steady state. Another set of assets that are important are the assets that go into producing the cars. So, price of gasoline goes up, everybody wants to run out and buy small cars. Even if people can adjust their purchase patterns as much as they want instantaneously, we still get slow adjustment, right? Because the purchase pattern of cars shifts dramatically towards small cars away from big cars, but it still takes time for the stock of cars to reach bottom, because we still have the big cars from the past. But what if it takes time to be able to build small cars? What's going to happen now? Well, that's going to slow it down even more, because even though everybody wants to buy a small car day one, we don't have the capacity. So the assets that are used to produce the cars actually see they're going to have to be built up, and as they're built up over time, that's going to help us converge. Now, you talked about technology, and we wouldn't get all the way back. What does that correspond to? What are you assuming about the depreciation rate of technology?
Well, I assume there was knowledge, which once generated is never lost.
That's the key, right? You're assuming that the depreciation rate of knowledge is 0. If the depreciation rate of knowledge is 0, then the convergence time to the steady state is infinite. So we never get back to the steady state that we were at the beginning. So I think that's the easy way to think about it, is the half-life of getting back to the time it takes to get to the steady state depends on the depreciation rate of the relevant assets. Technology may be thought of as an asset that has 0 depreciation. Now, it's not quite that simple, though, because if future investment can adjust based on what's happened in the past, then you can still have future investment slow down enough that you actually get back to the technology you would have been at anyway. Even in a static world, you wouldn't. But anyway, that's kind of the rough idea that happens there. So when you think about, so for example, in the car market, it takes us 5-10 years to maybe make a big full adjustment. It's what we saw in the 1980s with the response first to the rise in price, and then we saw the response to the fall in price.
despite changes in technology. Because
Despite
as you said
changes in
earlier,
technology.
people adjust their driving and other things when they have more efficient cars. So in terms of, what people were doing, it didn't look that different in like late 80s as compared to what it was before the price increase, right?
Absolutely, absolutely. Any question? Now, if you talked about home energy usage, the adjustment is faster or slower? How long does it take to get to the long run in terms of home energy usage? How long do buildings last? Last a long time. So the home energy response is an even more slowed down response because it takes even more time to make the adjustment. I mean, we have lots of old homes that aren't very efficient, but that have been around for a very long period of time. Okay, so you get an even slower adjustment. Yeah?
I thought what you were going to say about the technology is that maybe that the new short-run supply curve, once the prices go back down from 1975, is that short-run supply curve
Demand
would be more demand curve would be more elastic, because it's you have maybe you have like other things around, kind of the economy is going through something that it's seen before.
Oh, I agree. I'm going to get back to that later. I agree with you. That this is a very interesting question, which is what determines the elasticity of supply and what determines the elasticity of demand? We know fundamentally when it comes to the elasticity of demand, one of the key determinants is the availability of substitutes. And when will there be lots of substitutes? Let's say I have a market. Here's demand. Here's the supply curve. And in this marketplace, the supply curve never moves. Supply curve is always where it is. Now compare that to a market where kind of you might have had the same demand, but now supply moves around. Do you think that all else equal, this good and this good are going to have the same number of substitutes? Or do you think that this good people are going to invest to develop lots of substitutes? Very important notion that the elasticity of demand is likely to be a function of the variability of supply and vice versa. Great example. Think about an asset that has very variable demand. Construction of housing in a given neighborhood. Right? If you were to look at, in a given city, look at housing production, how much do you think it would vary? How many houses would be produced in one year versus another? Like a big year of housing production in the city versus a little year of housing production in the city. Versus look at like haircuts in a popular year for haircuts and haircuts in an unpopular year for haircuts. What would be the difference? You think haircuts vary more or less than housing production?
Far less.
Far less. How much would housing production vary? Do you think you could find a city where it varied by a factor of 10? Yeah, easily.
Yeah.
Easily. So, if I'm in a market where production is going to vary by a factor of 10, from the low times to the high times, you think I'm going to have a factory that has fixed supply or relatively fixed supply in that world? So my capacity for producing housing is very unresponsive? Or do you think it's going to pay to use a lot of labor, not much fixed assets, and be able to move production up and down, right? You can have a much more elastic supply in the world where demand varies, and you're going to have much more elastic demand in a world where supply varies. So I think you make a very good point. You don't want to think about elasticity as this like God-given number. Somehow the elasticity is this exogenous number. That is, the degree of substitutes available And the speed with which people can take advantage of those substitutes is going to vary systematically with the amount of variation in price that you see in the market.
You
Good
see that
example.
in the housing market, also for the laborers.
Yes.
So, I mean, they know that a certain fraction of their time over a period of time that they're not going to be able to get jobs at good wages in the housing market. So they'll try to have skills or alternatives that they turn to when housing demand is down. So they're moving in and out along with, you know, what the factory side is doing.
Yeah, so you ever wonder why construction workers like fishing? Right? Not endogenous, right? It's endogenous, right? That is, if you know you're going to be laid off, good idea to have a fishing boat and be able to go fishing, right? I mean, it's complementary with being a construction worker, right? So, whereas, you know, because you're going to have the free time. You're going to have times when things turn down.
Things for that your own, you know, maintenance in your house.
Absolutely.
For your unemployed time.
There's a lot of things you can do. So one lesson I think is important. Now, we're going to talk about this later, but we might as well get it out of the way now. One of the reasons why the mid-70s oil shock was so disruptive was what? What did the history of oil prices look like coming up to 1975? Oil prices not only had been low, but they had been stable. So people really hadn't accommodated themselves of how in the hell am I going to adjust when the price of oil triples. In contrast, the last 3 decades have seen oil prices going way up and way down. So it's not surprising that we handled the recent oil shock a lot better than we handled the earlier ones. We're better at it. We got practice. All right, we're better, yeah.
Why do the airlines suck so much then at accommodating shocks?
What do you mean by it sucks so much?
I mean, they just seem to be extremely sensitive when fuel prices change and when demand changes and stuff like that.
Well, because they have a lot of fixed assets.
But why don't they try to find ways to flatten out that supply curve and get better at redeploying those other countries or other uses or something like that?
Well, other countries doesn't help too much with fuel shocks, right?
Yeah.
Fuel shocks.
No, there have found ways. I mean, you know, the big emphasis has been on finding more fuel efficient planes, and so there's been a big shift in that direction, actually. But it takes a while because they have, as Kevin said, they have this very big stock that has been built up. And what do? It's a worldwide shock, so you should try to sell them off, that the price of these assets go down. This is the point maybe you should have stressed, that even in the car market, when the price of gasoline goes up, there's a big price adjustment in the fuel efficient cars versus
I'm going to do that later, because I'm going to talk about capital goods.
Okay.
So hold that on.
Another-
Yeah.
So United Airlines had never tried to hedge fuel prices, but then last September, when oil got to like 140, they locked in $140 oil.
But we have to be careful, right? Because hedging the price doesn't accomplish any adjustment. That's just like, I'm going to insure my shareholders. I'm going to take a bet on behalf of my shareholders, right? Because the opportunity cost of the oil still varies with the price of oil, whether you're hedged or not. So the amount of adjustment you should make is independent of whether you hedge. It's just a question of whether I want to take, in this case, a very bad bet on behalf of my shareholders. So, you know, the hedging is a separate event, really, from this adjustment process that.
But it could make a difference between going bankrupt and not going bankrupt.
Yeah, that's true. But that's a bet.
I know, it's a different issue.
Exactly. That's this question. So I guess, Jesse, one of the answers I would say is, first of all, airplanes are extremely durable. Cars last 7 years, airplanes last 40 years or whatever. They're very durable assets. They last a very long time.
Keep replacing parts and keep the plane going.
Yeah, they have a lot of cost even just sitting there. You know, the problem is, you know, they depreciate with use, but they also depreciate even if you don't use them. That's one of the problems. Even if you mothball them and sit them in the desert, which is what people try to do with planes, they actually depreciate a fair amount. So they have a lot of cost whether you use them or not.
They depreciate or they become more obsolete relative to the
Both.
competition?
Both.
Certainly obsolescence is important.
But they also depreciate. And they also depreciate that they just deteriorate with age. So right, they have a lot of problems with trying to bring these planes back. It's a little costly to bring these planes back from being mothballed. Any other questions?
One point I think you might, is worth making, going back to the changes historically in wages and the price of capital changing very little. The wage changes were huge, as you stressed. And these were, people say, well, what was the source of it? You didn't have labor unions. Let's say if you look at the United States, you really had nothing in the way of labor unions until 1930. Nevertheless, you had this big increase in wages. So competitive forces can operate very powerful with regard to labor as well as capital. I think that's a good lesson that people misunderstand often.
Absolutely. The other thing somebody asked me at the break is, what do you mean by this term delta R minus delta P? Well, that's the change in R over P, which is equal to the change in the rental price of capital divided by the price of output. So the way to think about this is how much does it cost to rent a machine relative to the price of output. So this is like the rental price of a hammer to the price of a haircut, something like that. And so this thing hasn't changed very much. In fact, if anything, it's probably gone down a little bit because the rental price of capital goods is the price of capital goods has declined somewhat relative to the price of consumption goods. Yeah.
Isn't there any specific reason we are focusing on CRS? Is it only based on we observe SL and SKs?
Well, no, there's three reasons for focus. Good question, very good question. Three reasons to focus on CRS. One reason is kind of a kind of justification. Think about a world in which we can replicate production units. So we're producing, Starbucks coffee out of a store, and we want to produce twice as much Starbucks coffee. What do? We just produce a second store just like the first one. We have twice as much capital, twice as much labor, twice as many coffee beans, and we get twice as much coffee. Okay, so the argument is we should have roughly constant returns to scale if we can expand the economy. Certainly shouldn't have diminishing returns if we can just replicate what we had already. Now, for industries that use natural resources, we know that doesn't quite work. You can't double the size of Major League Baseball and keep the quality of pitching constant, right? It's going to go down. But most industries are not so specific to natural resources, so we can think this replication argument seems to work pretty well.
Well, still, you can interpret that as CRS with some factors relatively fixed.
Yes,
right?
so it would be CRS. It would be CRS.
Be useful, it's still a useful
Yeah.
framework.
Exactly. So we can have CRS for one reason would be this argument that you can replicate. Okay. Another one is kind of empirically. It seems to fit the data pretty well. That is, the CRS assumption seems to fit the data reasonably well. A third argument is more of almost like an expedience argument. And let me try to explain this. That it's a good thing the world looks like CRS, otherwise we'd be in real trouble. And I'll explain why. Because think about, here's L and K. I'm trying to learn about this production function. Here's the equilibrium in 1950. L 1950, K 1950. Now, then I moved to 1960, 1970, 1980, whatever. All right? And I know what does this isoquant look like? What's the curvature of this thing? Now, in a world in which I don't have CRS, it's really hard to learn anything. Because what happened in 1950 is on a different isoquant than what happened in 1960. If I allow for arbitrary scale effects, I'm kind of sunk. The ability to learn anything I never get two observations on the same isoform. What I need is to have some way to kind of collapse this picture down, to sort of make it stationary. And one way to think about CRS, it's a really easy way to make the data stationary. It allows us to say, look, all that matters is L over K. So I can shrink all these points and put them effectively on one isopoint. So it actually is a very powerful tool for kind of taking a non-stationary world and making it stationary. You're assuming that scale doesn't matter. We have some good justifications for why scale shouldn't matter. But the fact that it doesn't matter allows us to view all this data from a single lens, that we're looking at kind of like a single isopoint. So it actually turns out to be very much our friend. Same is true cross-sectionally. I got a big firm and a little firm, or a big country and a little country. If you allow for arbitrary scale effects, you could say, well, the reason this country does something different than that one is because they're bigger. And that's the end of the story. So it really is kind of a stationarity assumption as well. So they're both good theoretical reasons, but also I think, thank God there are good reasons, because it really makes the world a lot easier. Makes the world much more stationary from our perspective. Any questions that people have? Okay, so we got two things we could do. We can either go on and do the oil problem, or we can go on and talk a little bit about capital. Finish up our discussion of capitalism. Jesse, you're the man in charge. Any feeling as to which way we ought to go?
Well, I just walked in a few minutes ago, so.
No.
What have you done so far?
Capital. Talk some more about capital and kind of lay out the basic theory of capital. Or go ahead and.
How far are we into the oil
I
problem?
think it's better to go up with the
Started out.
capital, because you really made it.
We haven't started
start
on
on that already.
What?
I was just asking how far we were.
No, we touched on the oil problem, but not so much from the point of view of the problem itself, or from other things.
I would vote for that, but.
You vote for the oil problem, and Gary votes for capital. So, hey, you're the tiebreaker.
Emily?
I don't, no, I'm not gonna vote. I'm not voting between my husband and Gary Becker. Doesn't seem like a fair thing to ask.
You're the tiebreaker, Kevin.
All right. All right. You guys tired of seeing equations? We'll talk. Well. All right. We'll come back and do capital tomorrow. Let's go ahead. We promised you guys the oil problem, so let's do that. Let's take what we've done so far and see if we can do the oil problem. So if everybody has the problem. Now remember, this part you're going to have to work. You guys are going to have to do work too. So. And basically it says, in recent years, the price of oil has risen substantially, from less than $30 to almost $150 a barrel. It's now back down and then back up a little. What's it today?
72.
What?
72.
72. Okay. So it's still more than double, roughly triple from where it was not too long ago.
How does it compare real value compared to?
72 is below 80. $72 would be below 82.
Below 82.
Below 82.
You know, you have to be careful about not thinking in nominal terms when you because this is not it's far. I think it's pretty far from the highest real value of oil as we look.
Yeah, 150 was when it was at 150. That was the highest real
I
value.
think it's about 110 or 120.
Yeah, it's around there.
back.
2007, prices got very close to where we were in 2008. Early 2008, they were about there. Then when they really got high in late 2008, they were well above where they were in 82. All right. So first of all, we're going to say, how much will the U.S. lose due to the rise in the price of oil? That's an easy one. How much does the U.S. lose as the price of oil rises? How long would it take you to calculate that number?
The difference between your increase in exports and the increase in imports.
Yeah, I mean, it's a pretty easy picture, right? We have oil, price of oil, demand for oil, supply of oil. This is the US supply, this is the US demand. We have some initial price that's down here. The oil 0. Price of oil rises. The oil 1. The loss to the US. Consumer surplus falls by this amount. Producer surplus rises by this amount. So the net loss is this trapezoid here, which probably the easiest way to calculate that is take oil imports, pre-price increase, oil imports, post-price increase, take an average of those two, multiply it by the change in price, and you're done. So that's an easy one. How much does the US lose? You can calculate just off of imports. If in like 2007, we were importing about $300 billion a year in oil. So if the price of oil doubles, you get a loss of like $300 billion. It's a big number. It's a big number. Okay, so that's a very easy one. It requires minimal data. Just as we said last time, these welfare first order calculations, you don't need to really know any elasticities. You get a good approximation just off of the quantities themselves. All you need to know is how much imports we had, and we can translate that into a loss to the U.S.
Substitution effects are not relevant to this first order.
Yeah, I mean, yeah, exactly. And you've accounted for substitution in some ways if you use the combination of beginning and end. You kind of allowed for substitution. You did that kind of Fisher approximation we talked about last time. If you just use the starting quantities, it'll be too big. If you just use the ending quantities, it'll be too small. Okay? All right, any questions that people have? That's an easy one. How much will the rise in oil prices reduce real wages for U.S. workers? How are we going to tackle that one? Any ideas?
To calculate the change in the price of the share of the oil.
Okay, there's a couple approaches. One is to think about oil only as a consumption unit, right? And you'd want to know what's the percentage change in the price of oil and what's the share of oil in consumption, right? Is that right? Is that how much they're going to lose? Remember our problem yesterday with soybeans and corn? Was the gain to farmers limited to a rise in the price of corn times the amount of corn they were selling? No. Those farmers also got bigger returns on their soybeans because soybeans were a substitute for corn. What does that suggest? What's going to happen when oil prices rise? Yeah.
People are basically going to get on the L. They're going to substitute away from.
Okay, but remember, that's second order. What's the first order thing that's going to happen?
Workers who switch to the oil industry to workers.
Well, okay, you got a little bit of that, but even more important, would oil prices be,
Natural gas, coal, and other energy prices.
Exactly. That is just like the rise in the price of corn pushed up the price of soybeans in our corn example. A rise in the price of oil is going to raise the price of other forms of energy. So, the formula you would think about would be the share of oil times delta P oil. Right, that would be our percentage change in the price of oil. But what you'd like to do would probably be something like the SO plus the share of other energy times, I'll call it theta, times delta P oil, where theta is the elasticity of other energy prices with respect to oil. That's probably how you want to think about it, that those other energy prices might also be driven up by the price of oil. Yeah?
That's income of some of the, I mean, how it.
I'm going to get there in a second. Okay, think about a world in which we only imported oil. In fact, we imported all our energy. That is, this is a world in which we're non-producers of oil or other energy. So the world price of oil goes up. This is like I'm a price taker, right? The world price of oil goes up. When the price of oil goes up, that pushes up the price of all this other stuff I import, and boom, respect to the price of oil. Okay? All right, people understand how that works? All right, so that's what happens. So this is if oil was only a consumption good. That is, we didn't produce oil at all. Okay, so that's a complicated world. Yeah?
The reason we're starting to bring in the response of this other thing is just because this oil shock isn't really the only thing that happened. Is that what you're saying?
No.
Why isn't the first answer the same, the right way to approach this if it's just a consumption good?
No, let's assume that there were two kinds of oil. There were red oil and blue oil. And arbitrage in the market meant blue oil sold for the same price as red oil. And there was a reduction in the supply of red oil, which caused the price of red oil to go up. How much we would lose would be on the blue oil as well. For every dollar the red oil went up in price, the blue oil is going to go up as well.
Why doesn't that first order approach work here? It's just because the substitution is enormous.
Well, no, because let's assume we couldn't substitute at all. It doesn't matter whether we can substitute. What is happening is we're going to use our same formula. We're going to use...
You're saying we need to take a total derivative.
We need to take a total derivative. We ought to look at all the price changes. And for example, let's say we had an export good that was complementary to oil. Well, then we'd have to subtract that. Like if we export oil drilling equipment, and when the price of oil goes up, suddenly our oil drilling equipment becomes more valuable, so we can export more oil. We'd have to subtract that from this calculation.
So we subtract the induced increase in the price of sort of all our imports, we add that, and then we subtract the induced increase in the prices of all our exports.
Correct. Correct. Okay? Now, you might say, well, what if we don't import it? What if it's produced domestically? Now it's getting a little tricky. Well, let's assume it's produced domestically, doesn't use labor, doesn't use workers. Then it's true that it's not a loss to the country as a whole, but it would still be a transfer from workers to the owners of that natural resource. So the guys who own the resources and the oil and the coal in Pennsylvania and the guys who own natural gas in Texas would be getting a transfer from workers. So it wouldn't add to the U.S. loss as a whole, but it would add to the worker loss. So this gets added to the loss to the U.S. as a whole. If it's imported, it gets added to the loss of workers if they are not on the other side of that transaction. Okay, question? Yeah?
So when we did that first exercise, why didn't we take into account the supply and demand of the other?
We should have. We should have said, this is what Gary was saying a moment ago, we should go back and say, okay, we have to look at all the induced changes in prices of other inputs. Now, I didn't worry about it because actually for these other energy stocks, we don't import very much. We don't import very much natural gas. We don't import very much coal. Those are mostly domestically supplied.
We're not net buyers of those.
We're not net buyers of them. Workers might be net buyers of them, but the country as a whole isn't net buyers of them. And what matters in these calculations is what you're a net buyer of. If you're supplying it to yourself, you're on both sides of the transaction. So when the price goes up, it's true the guys who are buying it pay more, but the guys who are selling it receive more, so that price change washes on first order. Okay?
Just like that question we asked in that survey about housing, isn't it?
Yeah, it's just like the housing question. That is, when the price of my house goes up, am I better off? The answer is, if I plan on living there for a long time, no. Because my value of a house goes up exactly the same amount as my cost of the house goes up, and it has no real wealth effect on me when my housing price goes up in value.
And if you don't have a house and you plan to go into the market, you're worse off.
Yes.
And
And if I'm an old guy who's planning on retiring and leaving, I might be better off.
That's been greatly misunderstood in the recent period when housing prices went up.
Okay? Now, this is oil just as a consumption good, but we know oil is also an important input into production, and as is energy as a whole. So, let's go back to our formula. Remember that formula I put on the board earlier? Let's now think about Y equals F of L, K, and E. Output is a function of labor, capital, and energy. And energy is produced using coal, oil, natural gas, nuclear energy, all that other junk. Okay? So, we have our equation, delta P equals SL delta W plus SK delta R plus SE delta E. Okay? So we don't have any technological change. We're just assuming technology is unaffected by this price of oil. I get 0 equals SL delta W minus delta P plus SK delta R minus delta P plus SE delta E minus delta P. So how would you analyze this problem? Any ideas? Let's do the long run. Long run's easy. What does the long run say? Delta R minus delta P, 0. No return on capital is constant. So this implies delta W minus delta P equals minus SE over SL, delta E minus delta P. So what does that say? That was supposed to be implied. Okay? So what does that say? How much would the real wage respond to a rise in the price of energy? Depends on the relative share of energy and labor in the production function. We'd have to calculate that. Now, you wouldn't want to use oil share here. You'd want to use energy share, and you'd want to allow for the fact that
regardless of whether it's imported or not.
No, this is whether it's imported or not. This would be the change in the real price of energy, which would typically be less than the change in the real price of oil, because the other prices don't respond one for one. So if you double the price of oil, price of gas and coal is not going to double. But nonetheless, the total effect is going to be bigger, right? It's an interesting question. Does the ability to substitute toward other forms of energy help workers or hurt workers? Does our ability to switch to coal and natural gas help workers or hurt workers? Yeah.
It depends to what degree the labor is used in production of this other energy. So if they use a lot of labor...
Let's assume that they just come out of the ground. Let's make it easy. Yeah, that's a tough problem. Let's assume they just come out of the ground.
Because owners of capital will...
No, let me give you a good example. Let's assume that these other things that come out of the ground were very elastically supplied, and they were very good substitutes for oil. Then what would happen? Well, then it would be very good for workers, because what would happen is the oil price would go up, but because we can substitute to other forms of energy, the overall cost of energy doesn't go up very much. And so in other words, when you look at energy as opposed to oil, this number gets bigger, but that number gets smaller. What would be the worst case for workers? What's the worst case for workers? Worst case is oil and other energy are very good substitutes, but other energy is very inelastically supplied. Why? Price of oil goes up on the world market. Everybody tries like hell to substitute toward other energy. They have great ability to substitute. But there's no, you can't increase the supply of this other stuff. So what's going to happen in the other energy market? Those prices are just going to get pushed up. And they're going to get pushed up just as much as the oil price went up, but they're going to provide no relief. They're not going to allow you to minimize your oil imports. So what's going to happen in that case is this is going to be equal to the change in the price of oil, but we're going to get penalized on all energy inputs. There's going to be a huge transfer from workers to owners of those energy inputs. The guy who owns oil in Texas and natural gas in Texas or coal in Pennsylvania, the owners of those assets are going to get a huge transfer from the workers as the inputs they provide become more valuable. Yeah?
Something that's confusing me is to do these comparative statics, don't we need to use a different primitive other than the price of oil as the shock? I mean, because like in the first case where there's a perfect substitute that's elastically supplied, how can the price of oil go up in equilibrium?
We just would stop using it.
So the market price of oil wouldn't adjust.
No, but just make the elasticity high and you're fine. What's going to happen is the bigger that elasticity is, the more we're going to be able to substitute in that direction and mitigate the effect of the rise in the price of oil. Okay?
In the short run, you would expect the substitutability would be low and the elasticity of supply would be low, right?
Yes, absolutely.
In the long run, they probably both increase.
Yeah, so it's not clear which way it goes, short run versus long run. That is, does the importance of these other oil inputs more important in the short run or the long run? In the short run, people are going to try to switch, but they can't. So it's going to push up their price. So our coal price is going to go up more in the short run and the long run. That's Gary's question. On the one hand, coal prices will tend to go up a lot in the short run because coal is very inelastically supplied in the short run. On the other hand, coal prices are going to go up less in the short run because not too many people can ship. So whether coal prices rise more in the short run or the long run, which means whether workers are hurt more or less in the short run than the long run, is really dependent on that war between the ability to supply and the ability to ship. It really is a war between who can build up assets faster. The guys who want to substitute into using oil, or coal, or the guys who have to produce coal. There are two fixed set of assets, the coal production assets and the coal use assets. The question is which one shifts faster. Okay. Any questions that people have? So this is roughly how you have to start thinking about it. Now you can build a complicated model, but the amount of work. But this is the basic ingredients that go into that model. So if you're building a model, what do we need to think about? We need to think about other energy. Other energy is critical in thinking about this because it affects our ability to substitute. It also affects the breadth of the price changes that occur. If you really want to get sophisticated, you might even think that we import energy embodied in other products, right? That is, we're not just importing energy as energy, we're importing energy in other products. So if you really want to start going general equilibrium, you can really start feeding through some of those price changes.
Of course, in some, particularly in the most recent period, if you look at the two earlier oil shocks, it originated in oil mainly,
yes,
and spread to these others. On the other hand, the most recent period, probably the worldwide increase in demand sort of led simultaneously to an increase in energy prices in general.
Yes, absolutely.
It wasn't so much a spread, but they're all being forced up by increased demand for energy in world usage.
Yeah, I can actually, I got some pictures I can show you if we have time. All right, now separate question. Question number 3. How will the increase in the price of oil affect real GDP? How do you begin to think about that? Anybody got an idea? How would you tackle that problem? How would you think about the ingredients that go into the real GDP response to oil?
So is this it's not the effect on the real welfare, it's on how GDP itself responds?
Yeah, and is real GDP, how we measure it, the production of goods and services in the United States, going to respond to the rise in the price of oil? Again, I think it's helpful to divide the world into two parts. Let's think about a world in which we don't produce energy at all. We're just importers. We're a country, we produce widgets, and we import oil. Okay? We export widgets and import oil. Okay? That's all we produce is widgets. That's our GDP, is how many widgets we produce. So, does that help? So let's think about, what was that other workhorse model I put on the board earlier today? U of C and L. Anybody see how you might put this into that model? Any thoughts? Okay, how about consumption? C equals C of X, which is our widgets, and O, which is oil. So consumption is some mixture of widgets and oil. Okay. P of X equals 1 over productivity widgets. And the price of widgets, think of everything in terms of labor. It's, this is how many widgets we can produce per hour. So the price of widgets is just the wage rate divided by that. So how would we think about the price of oil in this world? How does the price of oil affect the economy in this world? How does my widget producing country get affected by the price of oil? Well, what changes? What's GDP in this world? What's GDP? No, well, GDP, how much we produce? X. Okay, GDP equals X. Let's let alpha equal the productivity in widgets. So X equals alpha times 1 minus L, right? That is, the output is just productivity times how much time we devote to this. Okay? So what's my budget constraint? I want a max over L, O, and X. Okay, those are my choice variables. What's my budget constraint? My utilities U of C of O and X, comma L. What's my budget constraint? Alpha times 1 minus L, which is how many widgets I produce, minus how many widgets I eat, right? Because this is how many widgets I eat, has to be equal to what? That's my exports of widgets, has to be equal to price of oil Tanto. The price of oil is the price of oil in terms of widgets. So that's my budget constraint. It says the amount of widgets I export has to be equal to the value of the oil I import. Okay. Anybody see where I'm headed here?
Something like labor supply.
Exactly. That is, what's going to determine whether GDP goes up or down? A rise in the price of oil raises the price of consumption, which effectively lowers the real wage. And then GDP in this world is going to go up or down depending on whether the income effect more than outweighs the substitution effect. There's going to be an income effect to work harder because oil's more expensive. I got to work harder to pay for the oil that I want to import. On the other hand, there's going to be a substitution effect that says, geez, I don't get as much consumption for a given amount of work, so I'm going to work less hard. So the impact of the rise in the price of oil on GDP is going to have very offsetting effects. On the one hand, it makes us want to work harder because we're poorer. On the other hand, it makes us want to work less hard because the return to work is lower. It takes more hours of work to get a barrel of oil than it used to. When the price of oil is $150 versus $15, which it's actually done, that takes 10 times as many hours of work to get a barrel of oil as it used to. Yeah?
Wouldn't you think the value of leisure depends on oil, like driving, vacations, travel?
Absolutely. Absolutely. So what you want to do is what you're saying is this idea, the way I modeled it here is I sort of assumed consumption and leisure was separable. A more general utility function might have O, X, and L in it. All right? Now, the advantage of this is it would allow me to entertain a wider range of things. The disadvantage, of course, is I'm not going to be able to rely as much as on empirical evidence. If I think of this framework, I have lots of information about how people respond to wages and things like that. This is a general problem. As you expand your model and make it more general, you make it more able to fit a wider range of facts, but also harder to estimate. In fact, a little footnote. How many parameters does a too-good model have? Too-good model of consumption. How many parameters? Anybody know? Local. Local. Think about local. Too-good model of consumption. U of C and L, any too-good consumption model. How many parameters? How many? 3. You have one share parameter, which is how much I spend on each good in shares. One substitution parameter. And one income parameter. Adding up and homogeneity and all those restrictions tell me there's only one share parameter, one substitution parameter, and one income parameter. That's it. That's all there is to it. You can think about it as the share of good 1, elasticity of substitution sigma, and the income elasticity for good 1. Because if I know the share of good 1, I automatically know the share of good 2. If I know the income elasticity for good 1 and I know the shares, I know the income elasticity of good 2. And once I know any one substitution parameter, I know all the other ones from adding up and homogeneity. So there are 3 parameters in a too-good model. How many parameters in a 3-good model? Two shares, 2 income. How many substitution? Once I know 2 shares, I know the third. Once I know 2 of the income elasticities, I know the third. How many substitution? It's always equal to the number of off-diagonal elements below the diagonals. It's 3. 7 parameters. So this change here, from here to here, you can see how much more information I'm going to need. So if I think this is pretty good approximation, this is a good way to work. Or what we'll talk about when Gary talks, when he talks about household production, we'll figure out ways that even if we want to allow oil to come into the household, we're going to restrict it in such a way that effectively we're back to the 2 good world. Because a world with 3 parameters is a heck of a lot easier than a world with 7 parameters, particularly given what are easy. This is easy, this is almost easy, and this one is the hard one. The increase in the parameters comes in the hardest ones to identify, which are the substitution parameters. 4 goods, you end up with 3 shares, 3 income, and 6 substitution. You end up with 12 parameters. That's why you see economists work so much with 2 good utility, because the parameter explosion is just kills you. That is, trying to deal with a 12 parameter problem. This is just for a local approximation. Forget about how things change as we move away from local. But even for a local approximation, my 2 good world has 3 parameters, of which one is easy, which is the share. Income elasticities aren't so hard. This is the only hard one. Here I got 12 parameters, of which 6 of them are difficult to identify empirically. So that's why there's such a primacy on keeping the model simple. If you can keep it simple, you have so much more power to say something.
Yeah, this is a big difference between sort of economic theory, micro and macro, as an engine of analysis to really use it for something, and sort of the elegance of it. I mean, the top formulation applied to n number of goods. Well, you know, that's a more elegant formulation, most general formulation. For some sort of general results, it's useful to think of it that way. But if you ever want to use it, you're not going to use that model. It's just impossible to use it.
Yeah, I mean, I think in answer to your question, what you might want to think about doing is you might want to stick with this formulation, but you might want to think about splitting your time between different kinds of uses, uses that don't use energy, uses that do use energy but are not work, and then work time. Kind of split it between those 3. And then we can stick with kind of a 2 good view of the world in which we have this consumption aggregate, which depends on, that's the household production. Yeah?
Can I ask some questions about parsimony?
Sure.
So if you, I mean, you said, you know, if you think that the 2 good model is a good approximation, stick with that. But how would you know that if you don't, if it's so hard to estimate the parameters of the 3 good model, how would you know that your 2 good model is a good approximation?
Well, there are a couple of ways to go. One is, for purposes of impacts, you could look at something like shares of different things in different activities. So, for example, let's say I have 2 goods, and I'm worried about substitution between those 2 goods. If they have like the same share of oil, like the share of oil doesn't matter, doesn't differ between the 2, then I don't really care how substitutable those 2 goods are, and the shares will allow me to get around that. So that's one way you can know it's a pretty good approximation. So for example, there isn't going to be much substitution between lawyers and doctors, because the amount of energy usage in medical and legal services is pretty similar. So there's not going to be much. That's a dimension on which expanding my model and learning about that substitution.
Commodity approach to reducing.
Absolutely. We're going to have a composite commodity approach. That's why there's a relationship between this parsimony and all these things we've been talking about up till now, which is these share-based measures of how prices are effective prices are going to respond? How does the cost of different types of inputs? On the other hand, the other way to think about it is you can think about some fixed proportions world in which what you want to do, remember when I talked earlier about importing oil and other products? If you sort of say this other product is a composite of oil and something else, then what we might want to do is remeasure how we measure oil imports, where we not only consider the oil imported as oil, but the oil imported as part of something else, and then proceed as if oil wasn't used in these other inputs. The same as like you were saying, I got a vacation. Well, I might say the oil used in vacation, I'm going to put that into my oil, into some oil consumption.
Yeah, but Jesse, you're raising a general question. How do you know when you have a simple theory is working sufficiently well? You don't have to get more complicated.
One is kind of whether it works. I mean,
yeah, right.
That's probably the biggest test.
If it seems to be doing well, I mean, there's no hard and fast rule about when you know, but if it looks pretty good.
But if you had power to know how good it was doing, then at some level you could probably generalize it and estimate the more general model. I guess that's not.
It depends. I mean.
Well, but one thing I think is true along what you're saying. Often the advantage of using a simpler model, if you apply it, it may work reasonably well, but then you begin to see how to complicate it more readily. And if you start with a complicated model, often it's confusing to you. You start with a simpler model, you start applying it, okay, I can extend it in this way.
You can see more easily what it's missing,
yeah,
as opposed to starting with the more general model where you can't see what the generality bought you as easily.
Exactly. I think that's how actual theory operates in terms of trying to look at a particular problem.
But also simple models are often way over-identified. So you actually can see how well they're doing on a variety of different dimensions. I sort of think about like the work Larry Katz and I did on kind of like substitution between high school and college labor. I mean, that model was, there were multiple out-of-sample predictions and all kinds of other stuff that you can make using that model because it was so simple. It had lots of predictions about what would happen. And the fact that it could fit 4 or 5 different things kind of made you feel much more comfortable that it was working pretty well. Now that doesn't mean that all of them are right? It just sort of says, I'm either making consistent errors or, the model seems to work pretty well. So, one of the advantages of these simple models is they're often way over-identified. So they give you some ability to check whether, in fact, they're at odds with the data. And when when they are at odds with the data, then, like Jerry said, they give you some idea how you have to expand it. But I would say how you learn you have to expand it is really 2 components. One is direct kind of contradictions of the model and the data. The other is the kind of things I was talking about before. You know why things should matter. You know that, for example, the share of oil differing across products is going to mean that's a dimension you might want to think about. So you can look at other things other than just the outcomes to say whether this is likely to be an okay approximation. It's just like what we talked about earlier. I did this stuff with the price of energy. Well, there's other things other than energy that are substitutes and complements. You have to decide I'm going to stop at some point. Otherwise, I just have some completely computable general equilibrium model and let everything change.
And we're in the end good, general end good.
Yeah, you have some general end good, general equilibrium problem. And the problem is that requires you to know a lot of things. You have that kind of trade-off where you're expanding the complexity of the model, which in principle could get you more accurate, but also requires more inputs. And I agree, it's a difficult trade-off to make. But what I like to do is I like to think about these models as sort of stage 1. This is like, when I first start thinking about a problem, what am I thinking about? Well, first of all, this tells me, in general, the effect on GDP isn't so clear. But it's a lot like kind of usual income and substitution.
The other point worth making, and even though if GDP goes up, you're still getting lower welfare.
There's no doubt. I mean, you're just choosing how you're taking your pain. You're either taking your pain by working harder to maintain your given level of consumption, or you're taking your pain by taking less consumption. And those are the 2 choices you had. The answer to number 1 told us how much we lost. The answer to number 4 said, how did you take your lumps, right? You either took it by reducing consumption and not working any harder, maybe even working less hard, or by by working harder and mitigating some of your loss in consumption. In general, what would we expect? What would we expect to see happen? What's going to happen to consumption? Total consumption. Widgets and oil combined. That's easy. What do you think would happen to total consumption, widgets and oil combined? Probably go down,
Gonna
right?
go up.
Consumption's more expensive, you're poorer, you're going to consume less. Income and substitution effects are going the same way for consumption. Less consumption for the substitution effect. Oil, you're worse off, less consumption. For leisure, it's tougher. You're poorer, so you want to work harder. On the other hand, the return to work is lower, so you're going to work less hard. Now, if oil is a strong complement to leisure, then we have to work in that other substitution effect, which is the direct impact of oil on the substitution between goods and leisure.
Now, from the previous oil shocks, or even from the most recent one, do we know anything about how, hours of work probably didn't move a heck of a lot.
No, they don't. Now, there's an interesting question, though. How would your model differ in the short run versus the long run? This is actually tricky. Any ideas? Any ideas why? So let's assume that income and substitution effects wipe out here, which is not a bad approximation in the world. They basically net out, so uncompensated labor supply doesn't respond much to the wage. So model says not much effect on GDP in the long run. Real consumption goes down because imports are more expensive, but total production doesn't change. What about in the short run? You think production is going to go up, down? Why might production go down in the short run even if it didn't go down in the long run? What's going to happen when the price of oil rises? Oil-intensive goods get more expensive. Less oil-intensive goods get less expensive. So what's going to happen to the mix of what people do, even if aggregate production stays fixed? What's going to happen? What's going to happen to consumption of oil-intensive goods? Go down. What's going to happen to production of oil-intensive goods, like energy? It's going to go up. So we're going to have a reallocation of people away from industries that consume oil toward industries that produce oil. Non-oil intensive goods are going to tend to expand relative to oil intensive goods on the consumption side and contract on the production side. How does that process of people being reallocated affect GDP? People just instantly move from activity A to activity B? Probably not. Costs something to move people across places. How does that show up? Well, a lot of it might show up as unemployment of both labor and capital, as capital and labor are being redeployed from one sector to the other. So you might have a short-run effect that was bigger than the long-run effect on measured GDP, because what's going to get counted is this reallocation cost. Now, does, in a real economic sense, GDP go down? Or not? You were really able to do the accounting right. Would it really be true that GDP went down as much as you thought? We're incurring all this cost of moving people from A to B and moving machines from A to B. Are we getting something in return for that? We better be, otherwise why in the hell are we doing it? What aren't we counting in those GDP figures?
So you look at it as an investment? investment?
Yeah, it is an investment, right? What we really would like to say is, I haven't increased the number of workers I have, but I've moved the workers from where they're less useful to they're more useful. If we had like a stock market that was measuring the value of those assets accurately, what would happen is that asset value would be appreciating because we're getting less, we're covering a cost because we're not producing as much, but it's being compensated for by an increase in asset value. So measured GDP would fall more in the short run than in the long run, although it's not clear that true GDP falls more in the short run than it does in the long run, once you take account of the fact that we're engaging in all this relocation and activity. Certainly the fall in GDP kind of overstates the cost. What we're doing is we're taking more cost today in order to suffer less cost in the future. Because we could have had more output today by keeping people where they were, but that would have meant less output in the future because they'd still be where they used to be. So what you really want to think of is maybe absent mobility, the shock might look like this. Let's assume absent mobility, the shock would look something like this. Instead, what happens is we get a shock that looks like that. And maybe, in fact, we get all the way back to where we started. That was our previous long-run picture. That we get a shock, and in the end, we get back to where we started. If we didn't move anybody, we would have got this. But when we move people, we get this. So what you would expect to probably see is an exaggeration in this case of the impact. But it's exactly that exaggeration that leads to the related recovery and the fact that we didn't have any long-run effect. We were able to mitigate the loss by sort of reallocating people elsewhere. Okay? So the short-run impact of an energy shock can be high in a world in which people have to reallocate. This was particularly important in 1975 because this transition was much more difficult because the economy was not well tuned to adjusting to oil price changes. This has been much less important in recent years because we're much more able to deal with energy price changes than we were in the past. Okay. People understand how that works? Yeah.
Does it also matter for the 1970s one if there was some other adjustments that went along with that were kind of queuing up?
Absolutely. That is, if you're sort of, and this depends on kind of the shape of the adjustment curve.
Yeah.
But if you have a world where there's like sharply rising cost of adjustment, you're already trying to make the adjustment in that direction. A better example is like the 80s, where we started going back to where we've been already. That was a relatively easy transition because you kind of had these assets that you could move back toward. So, in a quadratic adjustment cost world, none of that matters, but in a world that's a little more realistic in terms of what adjustment costs look like, kind of these reversal scenarios can be very easy because you take advantage of kind of the assets that are already in place.
But another issue raised by the reversal, and say explicitly the Iran-Iraq war that led to an increase in the price of oil, that was expected to be temporary. So if people expect the oil shock to be temporary rather than permanent, that also will lead to adjustments in labor supply, right?
That's tougher because when they expect it to be temporary, then what you can have is kind of that can go either two ways. Either people can say, I'll keep working because there's no use leaving, I'll just keep doing what I've been doing. The other one is, I'll just pause what I've been doing, I won't go find another job, I'll just wait for things to come back.
Shift your leisure over time.
Yeah, so it's a little bit like that energy problem that we did earlier with oil. They're kind of conflicting. Anytime, this is an important result, right? Anytime you're dealing with own price effects, short run and long run are always well ordered. When you kind of come to cross price effects, often they're very ambiguous because of exactly this kind of an issue. Just like we had with the oil price and energy price, and just like we have in this case with worker mobility. Cross effects, short run, long run, are much harder. Now you can sort it out because it depends on the mix of signs of those cross price derivatives, but it can be a little tricky. And here you have multiple goods. You have where you're located and how you allocate your leisure. All right, well, why don't we stop here because we're out of time. We can, maybe we'll finish this up quickly and tomorrow and then we'll go on. All right, why don't we stop here?